let's go ahead and knock out section 932, more systems of inequalities. In this lesson, we'll continue to investigate systems of inequalities as you work to solve a real-world problem with your team. So review what you learned about systems of inequalities in lesson 931 by graphing the system of inequalities below on graph paper. Carefully shade the region of points that make both inequalities true. So again, same thing I've been doing the last couple of videos. I'm going to jot these questions down. I'm going to bring them into the coordinate plane, and from there I will sort of rewrite the problem. So this is problem 977, and it's asking us to do y is greater than 2 to the x, and it is asking us to do x plus 4y is less than or equal to 4. So first thing, I can make my input-output table, which I always think is a good idea with the exponential curves. So if I plug in 0, I get 1. If I plug in 1, I get 2. If I plug in 2, I get 4. If I plug in 3, I get 8. And then if I go backwards, it's going to be 0.5, 0.25, etc. So negative 2 is a quarter, then a half, then 1, then 2. I think I missed 2. 2 is 4, 3 is 8. So we get that curve. It looks like it's going to be a dotted line for sure. So we can sort of put our dotted line. And it looks like we're going to shade above it. So again, I would expect 0, 0 to be false. 0 is greater than 2 to the 0. 0 is greater than 1 is false, so I didn't shade that one. Here, I definitely think it would probably be easier to put it in standard forms. I'm sorry, in the slope-intercept form. It's in standard form. So we're going to have negative x plus 4 there. We'll divide by 4. So y is less than or equal to negative 1/4 x plus 1. I'm going to go to 1 and put a point, and then I'm going to go down 1 and over 4, down 1 and over 4, which means I can go up 1 and over 4. This one appears to be a solid line. And again, I can graph below it. So it looks like my solution set's going to be over here. So negative 1, negative 2, negative 3, 1. Negative 3, 1 looks like a solid candidate to be true in both. So let's go ahead and plug in negative 3, 1 over here. I'm sorry. So we'll get that. And don't forget, this becomes 1 over 2 to the third, or 1 over 8. So 1 is bigger than 1/8, so that's true. And then if I plug in negative 3, 1 over here, I get 1 is less than or equal to negative 1/4 times negative 3 plus 1. So 1 is less than or equal to, that's going to be positive 3/4 plus 1. So 1 is less than or equal to 1 3/4, which again is also true. So we're going to get a graph that looks something like that. Hopefully yours looks nicer and neater. So, moving along, back to problem 978. 978 has a lot going on with it. So, it's a search and rescue. Essentially, this balloon took off and disappeared, and we're going to use some clues from some witnesses and stuff to see if we can figure out where the guy landed. So, it says, I'm completely lost, water everywhere. I can see both burners have failed. Wait, I see land. I'm going to try and land. I think it's... And those are the last words heard from Harold and his hot air balloon. The last time the balloon showed up on radar, it was near the Solomon Islands in the Pacific. So we know it's near the Solomon Islands at one point. Your team must determine where to send the search and rescue teams. Use the following reports along with the map. So we're going to have a map. It looks a little bit like that. A lot like that, actually. And look carefully for the information that will help you draw constraints. Again, constraints are sort of limitations of where he could possibly have been on where the balloon might be found. Give the search constraints to the search and rescue team as a system of inequalities. Be sure to identify the probable landing site on the map. Click in the right corner of the map to view it in Desmos. So I went ahead and I made a resource page that combines both the clues on the and the map so that we can sort of do this together. And again, I don't know. I guess we'll make this one black. We'll make this one green, and we'll make this one red. And that is how we will roll. So it says the balloon departed from the airport on the very tip of the Philippines, so up here, and the flight was supposed to fly out a straight path directly to the airport in French Polynesia. So it was supposed to go here. The balloon's last known location was at -1,000, +100, near the Solomon Islands. So that's some basic facts. Is it was supposed to do that. So if we go here, I don't know, do I have a straight line tool? I think I do. That might come in handy. Okay. So it was supposed to go there, right? But the last time we saw it was in the Solomon Islands, which leads me to believe that it was going south of where it was meant to be, if that makes sense. So I'm getting something like that. All right. Now it says the pilot's report from a nearby plane. We were on our way from Australia when we saw a hot air balloon sinking rapidly. I am certain that it crashed south of our flight plan. So they were in Australia. When we left Australia, we traveled 2,000 kilometers north for 3,000 kilometers east. So they were in Australia at the airport. So they were here. They went up to over 3. Do I have that right? 2 north, 3 east? 2 north, 3 east. Okay. So we're going to get something like this. And again, it says that they are, I am certain to crash south of our flight plan. So I can go over here, and I know that they crashed somewhere to the south. Finally, it says I was a passenger on a flight that flew directly from French Polynesia to Indonesia. So French Polynesia to Indonesia. French Polynesia to, I guess, Indonesia, right there. And it says I was looking at my window when I saw the balloon going down to the north of where we were flying. So it looks like it must be good old Samoa. Samoa is the only one that is true for black, red, and green. So that's where that thing must have landed. He saw land. He was going down into Samoa for safety reasons. Okay. Now we will go back to 932. I think that's all we need for part A. I think we need to go to part B. So yeah, we answered all that. So we will go 932 part B. Again, we've answered those questions. So let's see what else they have. So the last problem says, notice that each system of inequalities below contains the same boundary lines. So this is going to be like similar to what we did in problem 931, where we had sort of the same graph multiple times, and we just had to shade it differently depending on how they change the inequality sign. So again, I'm going to jump over to a coordinate plane, write down this problem 979, and we'll do it a couple different ways and sort of see what we come up with. So let's jump over to a coordinate plane. Again, I have y. Actually, let's do this. I have y is less than or equal 2/3 x plus 3, and I have y is greater than or equal to 2/3 x. And I probably should be clear about this. This is, let's do that. This is going to be problem 979A. So my y-intercept is 3. I'm going to go up 2 over 3, up 2 over 3, up 2 over 3. So I don't think this line is actually changing. I think the only thing that's changing, that didn't go well. The only thing that's changing is the way we're going to shade it, I believe. All right, this line was at 0, and then it's going to go up 2 over 3, up 2 over 3, up 2 over 3. So you can see we have some good old-fashioned parallel lines. And I hope that we kind of have an idea where this is headed already. I don't mean to be touching that, so. Oh, I see what's happening. Okay. Okay, so we have these two parallel lines. And A is asking us to, actually I should probably greater than or equal to 2/3 x. Jeez, I'm a mess right now. I apologize. When it's not your day, it's not your day. Okay, so the first one is asking us like to shade below the line. And this one is asking us to shade above the line. So our solution on A is going to be this part right in the middle. Hopefully we see that. Hopefully there's no questions there. Now when I go to B, they're changing the inequalities on me. So it's going to be less than or equal to here, and it's going to be less than or equal to here as well. So B is asking a slightly different question. So again, less than on this line is going to be here, and then now less than or equal to this line is going to be here. So my solution of B will be this bottom chunk down here, not the middle and not above. And finally, C is asking us to change this one. So C is telling us that this is greater than or equal to, and this is less than or equal to. So this one will be like this, and this one will be like this. And on this one, I want to be very clear here. There is no solution. This is only true for black, not red. This is true for neither. This is only true for red. So there's no solution that works on C. At that, I think we're done. But I just want to jump over real quick and double check to make sure I'm not missing anything. Looks like there's some learning log. Describe your method for graphing systems of inequalities for a student who has missed class the last couple days. Hopefully 932 makes sense. Kind of just a review and a word problem, really. All right, have a great day.